Hi, we're going to do a quick tutorial on how to find the equivalent resistance of circuits. Okay, and we're going to start off with a really simple series circuit. Here we have a 3 ohm resistor, a 5 ohm resistor, and a 10 ohm resistor all in series. Now the reason I know they're in series is because there's only one pathway around this loop. If there's one pathway, it's series. Now this is really simple. If you want to find the total equivalent resistance for a circuit like this, all you have to do is add all your resistances. So I take my 3 ohms, my 5 ohms, and my 10 ohms, and we add them together to get 18 ohms. Pretty straightforward. Okay, now let's look at a parallel circuit. The way I can spot that it's a parallel circuit is because it has nodes. Nodes are these places where the current can branch out. So if current comes out of the battery and hits this point right here, it can either go down through the 3 ohm resistor or up through the 6 ohm resistor. And that's what makes this parallel. Each one of these resistors has total access to the battery. Now how do I find the equivalent resistance here? Well, the formula for this says that 1 over the total resistance, or the equivalent resistance, equals 1 over the resistances in the circuit. Now, in our case, the resistances we're looking at are 1 over 3 and 1 over 6. At this point, you could put this into your calculator, something like 3 to the negative 1 plus 6 to the negative 1, and hit the answer. But that will not be the actual resistance, because if you do that, remember you're finding 1 over the total resistance. Okay, at that point, what you need to do is take that number that pops up, which in this case is 1/2, or 0.5, and you need to take that to the negative 1 power, and you get 2 ohms as your total resistance. Now, some of you who can do fractions pretty well will just see that the common denominator here is a 6, and I basically have 2/6, that's the same as 1/3, plus 1/6, which gives me 3/6, which is the same thing as 1/2, which means that then I can take the inverse of that and get my 2 ohms. Pretty straightforward stuff. Now, of course, the question becomes, well, what if I have more than 2 resistors? Can I keep going? Answer is absolutely. Let's say we had another resistor in parallel with these two, and this one happens to be 2 ohms. I could just extend this out. 1 over the total resistance equals 1 over 3 plus 1 over 6 plus 1 over 2, which when you add it all up actually comes to 1. If I take that to the negative 1 power, I still get 1, and 1 ohms would be my total equivalent resistance for this circuit. Let's take a look at a compound circuit. A compound circuit is neither parallel nor series, and it's got a little bit of both. Okay, if you look at this, it kind of looks parallel, but then you notice there are 2 resistors on this branch. Okay, so it's not as simple as before. It still has a couple nodes in it, which means there's parallel going on in here somewhere, but there's also series going on right here. These 2 resistors are on the same branch. A branch is a pathway between any 2 nodes. When you have 2 resistors, 2 or more resistors on the same branch, they're in series. Okay, if they're in series, that means we can combine them like we would combine anything in series. And what I'm going to do is I'm going to reduce this down to an equivalent circuit. This circuit has the ability to be reduced down because I can combine those 2 resistors up on top into an equivalent single resistor. And that's what I'm going to do here. A 2 and a 6 in series, just add them together and make an 8. This one has remained a 4. Now this is a simpler circuit. This is just 2 resistors in parallel, an 8 and a 4. At this point, we can add them up and find the equivalent resistance the way we did before. We're going to take 1 over 4 plus 1 over 8, which if you do a little bit of your fraction business, you're going to get 3/8. Now again, this is not the equivalent resistance, it's the inverse of the equivalent resistance, which means my equivalent resistance is 8/3, better known as let's put an equal in there, 2.67 ohms. So you see, this reduction of the circuit is kind of a useful way to do this. This compound circuit seems to be a little bit harder. We have a resistor now on the same branch as the battery. Charges that come out of this battery have to pass through this 4 ohm resistor no matter what. Then they can go either through the 6 ohm resistor or through the 3 ohm resistor. But this guy is getting included no matter what, this 4 ohm resistor. The only way we can deal with this is to start from the top and work our way in. Most of the time when you're reducing these circuits, you start from as far away from the battery as possible and work your way in. One of the big mistakes that my students want to do is they want to combine this 6 ohm and this 4 ohm resistor. They think they're in series because if you look at this, it kind of looks like a series situation, but it's never series if you cross a node. This node is right here between these two resistors. They are not on the same branch. You cannot combine them like that. So because that's the case, what we have to do is approach these ones out here first. We look at these and we say, hey, you know what? These are in parallel. So we can find the equivalent resistance of those two in parallel first and then see what happens. Okay, so I'm going to start off with 1/6 plus 1/3. We've done this before, so we kind of already know the outcome. This is 1/2, which is the inverse of the answer, which means it's 2 ohms. Now I'm going to draw an equivalent circuit for this. What I'm going to do is I'm going to draw that 4 ohm resistor right here. And then I'm going to replace both of these here with a single resistor in the place where the 6 ohm was. What we found was the equivalent resistance for that was 2 ohms. So I can put that there now. This looks like a simple series circuit, and it is. At this point, I can just add the two resistors. 2 ohms plus 4 ohms is 6 ohms. And the equivalent resistance of this circuit is 6 ohms.